Alright, so in this question, we're given a table with data for a reaction rate study, and we're asked to determine the overall rate law for the reaction. The first part of the question asks us to determine the order of the reaction with respect to H2 and justify our answer. So we start by looking at the table, and we see that when the concentration of H2 is doubled from 0.001 to 0.002, we see that the rate of formation also doubles from 1.82 to 3.64 times 10 to the negative 12. And so since doubling the H2 concentration results in just a doubling of the rate, the order of the reaction with respect to H2 is 1. For part B, we're asked to determine the order of the reaction with respect to Cl2. And we do a similar analysis. We look at experiment 3 and 2, in where the concentration of Cl2 is doubled. And looking at the results, we see that the reaction rate also doubles from 1.82 to 3.64. Thus, the order of the reaction with respect to Cl2 is also 1. Part C asks us to write the overall rate law for the reaction. This part is easy since we already determined the order of reaction with respect to each of the reactants. We can write that the rate is equal to, there's always going to be some rate constant. And from part A, we know that the order of the reaction with respect to H2 is 1. And from part B, we know that the order of reaction with respect to Cl2 is also 1. So our overall rate law is simply this. Part D asks us to write the units of the rate constant. We can also use the table to help us. Just from looking at the table, we see that the units for the rate of the reaction are given in moles over liters over seconds, and the concentrations are given moles over liters for both H2 and Cl2. So let's just plug in the units into the overall rate law equation that we've come up with. So we can say that moles per liter per second is equal to K times moles per liter times moles per liter. Now simply solve for K. Sorry, this should be an L. So multiply both sides of the equation by, so in order to get K by itself, we just multiply the equation, both sides, by liters over mole twice. So we get liters squared over moles squared times mole over liter second is equal to K times mole per liter, mole over liter, times liter squared, mole squared. So this all cancels. one of the moles cancels on this side, one of the liters cancels on one side, and we're left with K is equal to liters over moles over seconds. And you can just see that here we're left with 1 liters, a mole, and a second equal to K. Finally, part E says predict the initial rate of the reaction if the initial concentration of H2 is 0.003 moles per liter and the initial concentration of Cl2 is 0.0005 moles per liter. For this reaction, the initial concentration of Cl2 is the same as in experiment 1, but the initial concentration of H2 is 3 times as large. So if we look at experiment 1 right here. And because the reaction is first order with respect to each reactant, the initial rate of the reaction would be 5.46 times 10 to the negative 12th moles per liter per second, which is 3 times the rate of the initial rate of the reaction in experiment 1. So again, this answer is just 3 times the initial rate in experiment 1.